Hello everyone, my name is Priyanka and I welcome you all to Study Room. I hope you all are doing great. So today we will be studying chapter 8 of class 9, that is motion. So let's get started. So what do you understand by motion? A body is said to be in motion if it changes its position with respect to time. For example, if you're walking, it is motion. If you are swimming, it is motion. You can think of anything. Running is motion. Anything which involves your movement. So let's watch this video. So what do you think after watching this video? Is the car moving or the object outside the car moving? So simply, it depends on your reference. For the person who is sitting inside the car, for that person the car is not moving because he is moving with the car. So he can't see that the car is moving. For the person who is outside the car, for that person the car appears to be moving. So it depends on the reference. This means that an object may appear to be moving for one person and stationary for some other, as we can see in this case. So we often perceive an object to be in motion when its position changes with time. Like we can see that birds fly and fishes swim, planets and stars are moving, right? So we can relate like this. But there are some cases where we infer motion through indirect evidences. For example, we cannot see the motion of air, but we get to know about it by the movement of dust, just like we get to know about the wind by the movement of leaves. So through indirect evidences. So there are some situations where we cannot perceive motion by position change, just like the motion of air. So watch this video. So what do you think? What causes sunset and sunrise and changing of seasons? Is it due to the motion of earth? If this is so, then why don't we directly perceive the motion of earth? So this is simply because we, the people on earth, we are moving along with the earth. So we cannot perceive the motion of earth directly, right? So that's why we perceive the motion of earth with the help of seasons, right? With the help of seasons and sunrise, sunset. We perceive the motion of earth via these evidences, indirect evidences. Because we cannot directly perceive the motion of earth. So types of motion, we will be studying about 4 types of motion in this chapter. First is rectilinear motion, that is a straight line motion. Then circular motion, rotational motion, as the name suggests, rotation is involved. Periodic or vibratory motion, like your oscillatory motion. If you have ever seen like pendulums also. So these are your extreme positions and this is your mean position. So like the motion, mean to extreme position, then back to mean, then to extreme position. So this is your oscillatory or periodic motion, right? So some objects may move in a straight line, others may take a circular path, some may rotate and a few others may vibrate. There may be situations involving a combination of these. Maybe this and this can combine, or this and this. Like we can have motions which like a combination of motions, right? Correct. So description of motion. So to describe the position of an object, we need to specify a reference point called the origin. So as I told you that in the case of that car incident, the one we discussed earlier, in that very incident we saw that with respect to the person who is sitting inside the car is at rest. But for the person who is outside the car, for that person, the car is moving. So it depends on the reference. What is the reference? From where? The position from where we are observing. The position from where we are observing, that is your reference point. We are observing. Okay, so this is your reference point. So this matters. An object may appear to be moving for some person, and the same object may appear to be at rest for some person. For example, this car incident, right? So we specify reference point with respect to which position we are talking about, right? So for example, we say that railway station and the school are 2 kilometers away from each other. So our reference point is railway station. We are measuring from this very point to this very point, right? So reference matters a lot. Reference can change your interpretation. Reference can make something moving and at rest respectively. So description of motion. Let us consider the motion of an object along a straight line. O is the reference point. O is the reference point means this is the point from where we are measuring the distances. Okay. So let A, B and C represent the position of an object at different instants. At first the object moves through C and B and reaches A. So here what is happening, that there is an object which moves from here to here and then reaches here. So he is moving from O to A via C and B, right? Then it moves back along the same path and reaches C through B. After that, this object returns back from A to C. Okay. So what is the total distance? Let's calculate the total distance. Firstly, the object goes from O to A. So it's 60 plus 60 kilometers. Plus then it goes from C, it reaches A. Then it moves back along the same path and reaches C through B. Then he goes from A to C, right? 60 say 20, from 60 to 25. So how much is this? 35. So what is the total distance he is covering? It's 95 kilometers. Acha, if I am asking, alright, so if I ask you about the shortest distance he is covering. So if you want to calculate the shortest distance, he is starting from O. He took all the paths returning and his final position is C. So if I want to calculate the shortest distance of this object, it will be 25 kilometers. What will be the shortest distance if it directly goes from O to C? For the shortest distance, we see the starting position and the ending position. Our origin, our beginning point and the ending position, right? End point, right? So our starting point and end point. So we get to know that our shortest distance is 25 kilometers. For example, because he is traveling from O to A, then to C. So shortest distance he will be covering will be from OC, right? Will be OC, right? So OC is the shortest distance, which is 25 kilometers. So we have given a term to the shortest distance. The shortest distance covered is known as displacement. We call it displacement. Displacement is the shortest distance covered. For example, if a person travels from A to B, okay, and it's 5 meters, and then he travels from B to A, he comes back to A. Okay, so his total distance will be 5 plus 5, 10. And what will be his displacement? Displacement means shortest distance. His starting point is A. His ending point is also A in this case. So his displacement is 0. Simply. Okay. So yeah, this is what I've already explained you in the previous slide. Moving further. So displacement, as I told you, it is the shortest distance measured from initial to the final position of an object. Okay. So displacement has two components. For example, when we were talking about distance, we were talking only about its numerical value. Like we were covering 5 kilometer distance or 10 kilometer. We were only talking about the numerical value. But when we talk about displacement, we talk about shortest distance, right? Correct. So if we are talking about the shortest distance, then we also need the direction, because we can talk about the shortest distance only when we know the direction. Correct. So when we're talking about displacement, we have magnitude. Magnitude is your numerical value, as well as direction, because we need to know the direction in which the object is going, like the end point and the starting point. We need to know the direction, right? Then only we can calculate the shortest distance. So but when we're talking about distance, there's no need for direction, because no matter how long it is, we'll calculate the whole distance. But when we're talking about displacement, we're talking about the shortest distance, right? So shortest distance, we need direction for that. So here comes a new concept, that is, we have two kinds of quantities. This is some extra knowledge which I am giving you, which, like, you know, knowledge never goes waste, you always learn. We have scalar quantities and vector quantities. Scalar quantities are those which have only magnitude, which have only numerical value, which don't have any direction, just like your distance, speed, right? Time is your scalar quantity, right? Because you don't have any direction in time, right? But vector quantities are those which have magnitude as well as direction. For example, if we talk about displacement, that is your shortest distance. So displacement is a vector quantity. Okay. So we need numerical value and direction to specify displacement. We need both, so it is a vector quantity. So in the example, as I told you, so your displacement will be 25 kilometers because your shortest distance is 25 kilometers. So comparison between distance and displacement. The magnitude of displacement for a course of motion may be 0, but the corresponding distance covered is not equal to 0. As we saw in the previous case, which I showed you in the previous slides, that a person is going from A to B and he returned back to A. So his displacement is 0. Why is his displacement 0? Because for displacement, we only need starting point and ending point. We don't consider the path. Okay, displacement is independent of path. No matter how long paths the person is covering, what we need is the shortest distance. So for displacement, we just need your starting point and ending point, right? So the magnitude of displacement for a course of motion may be 0, as we saw in this case. If a person is returning to his original initial position, in that case your displacement is 0. And distance covered is not equal to 0. Of course, your total distance cannot be 0 because it is covering the entire journey, right? In the example, consider the object travels back to O, the final position coincides with the initial position, therefore the displacement is 0. However, the distance covered in the journey is this. Okay. So, comparison between distance and displacement. Distance and displacement are used to describe the overall motion of an object and to locate its final position with respect to its initial position at a given point, right? Okay, so some key points. Distance, for distance, it is dependent on path. It matters, like the whole journey matters. But for displacement, it is independent of path. That is, only your starting, initial and final points matter. Okay. So let's do this question. An object has moved through a distance. Can it have 0 displacement? So I think you are in a condition to tell this answer. Of course, yes, it can have 0 displacement. You can give any example, a return journey example, right? A person goes from A to B and return back to A. So the shortest distance he has to cover from A to A is 0, because the starting point is also A and ending point is also A. Moving further, question 2. A farmer moves along the boundary of a square field of side 10 meter in 40 seconds. There is a square field of side 10 meter, right? Square field, so all sides are equal. So he is covering this square field in 40 seconds. So he is covering 40 meters in 40 seconds. That means, right? Because he is covering the whole square field in 40 seconds. This means that he will cover 1 meter in 1 second, right? Correct. So which means that he will cover 10 meter in 10 seconds from unitary method, right? What will be the magnitude of displacement of the farmer at the end of 2 minutes 20 seconds from his initial position? So your 2 minutes 20 seconds is equal to how many seconds? 1 minute is 60 seconds. So that means 2 minutes is 2 into 60, that is 120 seconds plus 20 seconds, right? This one, which is your total will be, it's 140 seconds, right? So we have to calculate that if the farmer starts, if we label it A, B, C, D, and the farmer starts from here, okay? So after 140 seconds, at what point will he be? Okay. So first let's see them. He is taking right, we just need the starting point and the ending point. So what will we do? We'll just calculate this distance from A to C. Okay. So because this is the shortest distance from A to C, starting point and the ending point. So what will be this? We can apply Pythagoras Theorem here, because it is a square and this is 90 degree, and so we can consider this right triangle, right? So what will be AC? AC square is equals to 10 square plus 10 square, right? So AC square is equals to 200, which implies AC is equals to root 200. And what is root 200? If you don't know, you can calculate like this, okay? The easiest way out. So this is equals to 10 root 2 meters. So your magnitude of displacement after the end of 2 minutes 20 seconds will be 10 root 2 meters. Okay. So let's look at this question. Which of the following is true for displacement? It cannot be 0. Is it true or false? Of course it is false, as we have just discussed in the beginning that it can be 0 in a return journey, and there are many more examples. Return journey is just one example, right? So it is false. Its magnitude is greater than distance traveled by the object. Do you think it is ever possible that magnitude of shortest distance is greater than the distance itself? Never. It is also false. So let's hear the story of this hare and the tortoise race. So let's recall the story of the hare and the tortoise. The race is 50 meters. Let's begin the race. Okay. So there is one reference point, of course. With reference to that point, we will be measuring. Right. So they both will be starting from here. This is your reference point. This is the 50-meter race. Okay. So note the distance covered by hare and tortoise at every 5 minutes. Tabulate the reading. As we know, the winner is tortoise again. Okay. So let's look at the analysis of this race. So we see the distance travelled by hare and tortoise. Okay. Alright. Correct. So in 5 minutes, hare is travelling 10 meters, tortoise is travelling 5 meters. Then it just like that, the whole tabular form is given. Okay. So at the end we see that in 50 minutes, hare travels 40 meters and your tortoise travels 50 meters, right? So this is the analysis. So uniform and non-uniform motion. So if an object travels equal distances in equal intervals of time, it is said to be in uniform motion. If an object travels unequal distances in equal intervals of time, it is said to be non-uniform motion. For example, if I take an example of uniform and non-uniform motion, what can I say? 1 second, I'll just give you the example. So, for example, For example, there are 3 time intervals like 5 seconds, 10 seconds and 15 seconds, right? After 5 seconds, 10 seconds and 15 seconds. Here also, equal time intervals we are taking, okay? If a person is traveling 5 meters, then 10 meters, then 15 meters, he is traveling equal distances in equal intervals of time. 5 meters in this interval, 5 meters in this, plus 5, then plus 5. But so this is a uniform motion, right? If as your time is increasing, the distance is also increasing proportionally, right? But if we talk about a condition where, distance is unequal, for example, it was 10 meters, the car covers 10 meters in 5 seconds, then suppose 500 meters in next 10 seconds, and then 20 meters. I am taking one arbitrary case, right? So, when there are unequal distances in equal intervals of time, then it is your non-uniform motion. And when there are equal distances in equal intervals of time, it is your uniform motion. I hope this is clear, right? Equal distances in equal intervals of time, it's your uniform motion. So, let's talk about speed. What is speed? How much distance is covered in the time taken, right? That gives your speed. So, speed is the measure of rate of distance travelled by the object in unit time. So, whenever rate of distance comes, we are talking with respect to time, right? So, it is the measure of rate of distance travelled by the object in unit time. So, different objects may take different amounts of time to cover a given distance. Some of them move fast and some move slowly. The rate at which objects move can be very different. So, what is SI unit of speed? Since we know speed is distance upon time, we can calculate its SI unit by this formula. Distance, the SI unit of distance is meter and the SI unit of time is seconds. So, SI unit of speed is meter per second, or we can write it as meter second to power minus 1. Meter per second, we can write it in this form as well, right? So, this is your SI unit of speed. Other units of speed include centimeter per second and kilometer per hour. You can even measure speed in these units, but your SI, your standard unit is meter per second. To specify the speed, we require only its magnitude. As we talked about this is a scalar quantity, okay? Scalar quantity. Because we only need magnitude. We don't need direction for speed. So, what is average speed? Average speed is simply total distance travelled in total time taken. Okay. So, in most cases, objects will be in non-uniform motion. Therefore, we describe the rate of motion of such objects in terms of average speed. Okay. So, average speed is total distance travelled upon total time taken. So, let's do some examples of average speed. A car travels a distance of 100 km in 2 hours. Its average speed is 50 km per hour. The car might not have travelled at 50 km per hour all the time. So, if your average speed is 50 km per hour, it does not mean that your speed at every instant was 50 km per hour. Average speed means total distance covered upon total time taken. So, when we are talking about average speed, we are considering the total distance. So, you cannot say that, your speed was 50 km per hour at some instant. No, it wasn't. Maybe it was 45 km per hour, maybe it was something. But your average speed, that is your total distance upon total time taken, was 50 km per hour. This is what it means. Okay, so, next. Odometer and speedometer. As the name suggests, odo means distance. Okay, odo means distance. So, your odometer measures the distance travelled by the vehicle, and as the name suggests, speedometer. Speed, it is used to measure speed. Right. So, odo means distance. So, odometer is used to measure distance and speedometer is used to measure speed. A speedometer measures the speed of the vehicle in motion. It records the speed in kilometer per hour. What was your SI unit of speed? Meter per second. But your speedometer records it in kilometer per hour. Speedometer measures the speed of vehicle at a given instant of time. Let's move ahead. Let's do this question. An object travels 16 meters in 4 seconds and then another 16 meters in 2 seconds. What is the average speed? So as we know that average speed is equals to total distance travelled upon total time taken. This means, what is your total distance? He travels 16 meters in 4 seconds and 16 meters in 2 seconds. So total distance is 16 plus 16, that is your 32, is your total distance. And what is your total time? 4 seconds and 2 seconds. 4 plus 2, that is 6 seconds. So what will be your average speed? Your average speed will be 32 upon 6. That is approximately nearly equal to 5.3 meter per second, right? So one more thing, many of you do this mistake, so I'm telling you again and again, don't think that average, if it is average, so we'll do this like 16 by 4 is equals to 4 meter per second, and then 16 by 2, we are doing distance upon time, speed, 2 meter per second, and then we'll take the average of both of them like 4 plus 2 by 2. This is wrong. When we are talking about average speed, we are talking about total distance and total time. So this is how you will calculate this. You will take the total distance and total time. You will not take the average of both individual distances. That will be completely wrong. So now we will talk about the concept of velocity. So just like when we talk about distance, we talk about speed. In the similar fashion, when we talk about displacement, we talk about velocity. So as your speed is distance upon time, in the same way your velocity is displacement upon time. What was displacement? Displacement was your shortest distance, right? And displacement was your vector quantity because it involves direction also. Okay? Alright, correct. Okay, so velocity is displacement upon time. So let's just speed with direction. Okay, so we can also say that velocity is speed with direction, right? If we give direction to speed, that is your velocity. So what does that mean? That velocity is a scalar quantity or vector quantity? Of course, it is a vector quantity. So the rate of motion of an object can be more comprehensive if we specify its direction of motion along with its speed. The quantity that specifies both the magnitude and the direction is called velocity. If we talk about this, okay. So velocity is the speed of an object moving in a definite direction. Velocity of an object can be uniform or variable. It can be changed by changing the object's speed, direction of motion, or both. Speed and velocity have the same units, that is meter per second. Of course, if we talk about velocity, it is displacement upon time, right? And what is the SI unit of displacement? Since it is one kind of distance, it is the shortest distance, it is meters, and time, it is seconds. So it turns out to be meter per second, your SI unit for velocity, right? It's very simple. So now we'll talk about average velocity. So pay attention please, okay? So when an object is moving along a straight line at a variable speed, we can express the magnitude of its rate of motion in terms of average velocity. It is calculated in the same way as we calculate the average speed. Okay, so it is changing at uniform. Average velocity is given by arithmetic mean of initial velocity and final velocity. What is arithmetic mean? For example, your starting velocity is 5 and your final velocity is 10. What is the arithmetic mean of 5 and 10? It is 5 plus 10 by 2. That is the arithmetic mean, right? So how do we calculate the average velocity? We take the arithmetic mean of initial velocity and final velocity. So we denote initial velocity. What is initial velocity? Initial velocity means velocity at the beginning. U is your initial velocity. Initial means beginning. V is your final velocity. Okay. So it is the beginning velocity and it is the final velocity. And what is your average velocity? V average. What is the average velocity? Arithmetic mean of initial velocity and final velocity, that is U plus V by 2. So let's do this question. Distinguish between speed and velocity. I think you all can do this. We have studied a lot about this so far. Firstly, speed is your distance travelled per unit time, right? Speed is distance travelled per unit time. And your velocity is displacement, that is your shortest distance. Speed is distance travelled and velocity is shortest distance travelled per unit time. Travelled per unit time. What else you can say? Speed is a scalar quantity. It does not have direction. Does not have direction. Right, correct. And velocity has direction, so it is a vector quantity. It has direction. Speed only have magnitude and velocity has magnitude as well as direction. What else we can say? Both the SI unit of speed is also meter per second and velocity is also meter per second. Right. So, one more thing, velocity and speed. What else we can say? That velocity for a particular distance, velocity can be 0 because displacement can be 0. But for a particular distance travelled, speed can never be 0. Okay. Next, please. Under what conditions is the magnitude of average velocity of an object equal to that of average speed? Simply when object is moving in a straight line motion. What does that mean? Straight line motion, okay. When object is moving in a straight line motion, for example, an object is moving from A to B, just A to B, that's a straight line motion, a one-sided straight line motion, right? And the distance is 10 km. If a person is traveling from A to B, your distance is 10 km. And what is your displacement? Your displacement is also 10 km. So, whenever we are talking about straight line motion, we can say that average velocity can be equal to average speed, because distance will be equal to, it will only happen when distance equal to displacement, right? Average velocity will be equal to average speed only when distance is equal to displacement, and it is the case in the straight line motion. So, what does the odometer of an automobile measure? As we just studied, odo means distance and it measures the distance of the vehicle. Measures the distance of the automobile in kilometers. In kilometers, as we saw in that picture, right? Moving further, what does the path of an object look like when it is in uniform motion? So, whenever like an object is in uniform motion, this means that the object is covering equal distances in equal intervals of time, right? So, if we talk about the graph of this, so for example, in 2 seconds it is covering 2 meters. In 4 seconds it is covering, let's say, 4 meters. 6 seconds it is covering 6 meters. He is covering equal distance in equal intervals of time. So, when you will plot this, you will get a linear graph, a straight line graph. So, in a uniform motion, this is the type of graph we will be getting, okay. The path of an object will be a straight line. So, let's do this question. During an experiment, a signal from a spaceship reached the ground in 5 minutes. Your time is your 5 minutes, okay. The signal is reaching the ground in 5 minutes. What was the distance of spaceship from the ground station? The signal travels at the speed of this, and your speed is 3 into 10 to the power 8 meter per second, right? So, what is your distance? Your distance is simply speed multiplied by time, right? This is your distance. So, what is it? 3 into 10 to the power 8 into time is your 5 minutes. We need to convert. We can't use 5 here. It would be wrong because we are dealing with seconds, right? And SI unit of time is seconds. So, 5 into 60, because 1 minute is 60 seconds. So, 5 minutes is 300 seconds. So we'll multiply this with 300. What do we get? 9 into 10 to the power 10 meters. Okay. 900, because it will be 900 into 10 to the power 8. So 9 into 10 to the power 10 meters. This is your distance traveled. Distance of the spaceship from the ground station. So next question. The odometer of a car reads 2000 km at the start of the trip and 24 km at the end of the trip. So your odometer is measuring the distance, right? So it is measuring 2000 km in the start and 2400 km in the end. What does that mean? What is the distance covered? It is only 400 kilometers because it is starting from 2000 km, right? So this is our initial, this is our final distance. What is our distance covered? That is 400 meters. That is 2400 minus 2000. So we get that our distance covered is 400 kilometers. If the trip took 8 hours, time taken is 8 hours. Calculate the average speed of car in kilometer per hour and in meter per second. Okay. So your average speed is total distance travelled upon total time taken, right? So what is the total distance travelled? It is 400 kilometers. And what is the total time taken? 8 hours, right? So it is 50 kilometers per hour. Now if you have to even find it in meter per second, it is very easy. See, 1 kilometer is 1000 meters and 1 hour is 60 minutes into 60 seconds, that is 3600 seconds. So what are we supposed to do? For 50 km per hour, 50 km per hour into 1000 meters, because we want to convert into meters, upon 3600 seconds. So when we do this, we get the speed in average speed in meter per second. So let's calculate. Okay, so it is nearly equal to 13.8 meter per second. Let's move ahead. Usha swims in a 90 meter long pool. She covers 180 meters in 1 minute by swimming from one end to the other and back along the same straight line path. So there is a 90 meter long pool. She covers 180 meters in 1 minute. So she covers 180 meters in 1 minute. What does that mean? She covers 180 meters in 60 seconds, right? So what does that mean? How much, like she'll cover 1 meter in 60 by 180 seconds, and she'll cover 90 meters in 60 by 180 into 90 seconds, right? In 30 seconds, right? 30 seconds. She'll cover 90 meters in 30 seconds. Find the average speed and average velocity of Usha. Okay, so what is the average speed? Average speed is simply total distance upon total time taken, right? So what is the total distance? She covers 180 meters. So your total distance is 180 meters. Okay, and how much time does she take? She takes 60 seconds for 180 meters, right? So total time is also given. Wow. Okay, she takes 1 minute for 180 meters, right? She covers 180 meters in 1 minute by swimming from one end to the other and back along the same path. So she takes 60 seconds time, right? So what is her average speed? It is 3 meters per second. But if we talk about the average velocity, her average velocity is displacement upon time taken. And what is your displacement? Since she is coming back along the same straight path, for example, she is going 90 meters from here to here and she is coming back. So what is her initial point? Starting point is this. And what is her final point? Final point is also this. So what is her displacement? Her shortest distance covered is 0 upon time taken, right? And this is equal to 0 meter per second. So her average velocity is 0 and her average speed is 3 meter per second. So thank you so much for watching this video. We'll be covering acceleration in the next part and few more topics. So do revise, and if you have any doubts, then feel free to ask, and have fun. Stay safe. Bye bye.